Hello, everyone. Welcome to End-to-End Machine Learning Project Steps, Part 2. So just a quick review. These are the 8 major steps that you should follow through for any machine learning project. And then we stopped at step 5. These are the data potentially you can select from. So let's look at number 5, select and train a model. Let's take a look, right? So for this one, for example, if you want to run a housing pricing prediction model, if assuming that we just going to leverage the simplest method or algorithm, linear regression, then you could leverage what is already in scikit-learn from sklearn.linear_model import linear regression, and then you could run this by doing linear_reg, which is a linear regression, and then .fit using housing prepared and being the data, and then housing labels. And then that's it. That's your linear regression model in scikit-learn. And then you could also look at some of the metrics after you run through the model. So for example, you could look at the data and look at the labels, and then even just look at some of the predictions as always. We're going to look at some of this code later as well. So then, you have to be training and evaluating on the training set. Question you should be asking yourself would be, what would be the proper model? Is it a linear regression? Is it a decision tree? Or is it a random forest model? Or it could be anything that we're going to learn in this class. And then the best thing is you really don't want to just train your model on your training set and test the model on your training set as well, right? As we mentioned, you should balance between that variance and bias to find out the best model. So this approach is called cross-validation. So what you do is you randomly split the training set into 10 distinct subsets called 10 folds, and then you train it and evaluate the model 10 times, picking a different fold for evaluation every time and training on the other 9 folds. So what does that mean? That means you have 10 different chunks, and then you use 90%, 9 out of those 10 randomly as your training set, and then the other 10%, that chunk, as your test. And then you run a model on this randomly selected 9 sets, and then use the other one as a test. You do this multiple times so that it's going to be cross-validate your model. So this process is called cross-validation. And then k-fold cross-validation in this case would be 10 folds cross-validation. Here is snippets of the code. You can leverage model selection import cross-val score, and the cross-validation score is going to be use a specific model, and data and labels use some sort of scoring, and CV is number of cross-validation folds, which is at 10 that we just discussed. And then you can come back with tree RMSE scores from the model itself. The next step is fine-tune your model. Fine-tuning your model is really a process to continue to enhance your model. For example, in hyperparameter, in many cases, you need to leverage hyperparameters. Especially this here, use random forest regressor as an example. You can see that we can tune something called number of estimators. and it's going to perform some sort of grid search, a cross-validation method to find the best hyperparameter for your model. For example, here you're taking two things. One is you're just trying to estimate two things. One of them is n estimators. The other thing is max features that can, after you run through this grid search CV, you would be able to come back with the best hyperparameter you should be using in this model. And then this is continuation of the housing price example that we discussed earlier. What if we, instead of using linear regression, what if we use random forest? In random forest, you do have some hyperparameters that you need to estimate. And this is also going to be one of the homework, so you would be able to experiment on this part. Of course, you could also evaluate your final model on the test set, just as we mentioned earlier, to find the optimal model that balance between bias and variance. The next thing that you want to do is just to present your results. Present your results to technical audience, also to non-technical audience in your organization, to let them know why your method works, but also not only why it works, but also why it fits the business purpose really reasonably well. And the third thing, you would want to present your results to senior management, obtain approval for putting the model into production. Once that's ready, next thing that you want to do would be step 8, launch, monitor, and maintain your system. You productionize your model, continuously monitor your model performance. You maintain your system as time goes on. As time goes on, when you see some divergence of your model performance, you also improve your model and system as needed. Continuation of the model and system maintenance. And that's pretty much it in terms of end-to-end machine learning project. What you do is look at the big picture, frame the business problem, get the data, look at your data, prepare the data, start running some sort of models, fine-tune your model. After you finalize your model, present your solution to all the audience that's relevant in your organization. The last step, monitor and continue to maintain your model and system. Thank you.